Okay. Good evening. Welcome to day 22 of 100 days of studying data structures and algorithm. Sorry, I didn't set my time very well. I'll just go back and change this to script. Increase this to 75. All right. So today, what I'm going to do is just to I recently learned about the sliding window technique, and the objective of this session is to just practice what the sliding window technique is. Go over it, learn, and look at every other aspect of it um before I begin to solve questions on it. So it's it's the first time I'm trying out the sliding window technique, although I've heard of it before, and I thought it would be the next best subject to study for after learning about two pointers, right? They are sort of related. So I'm just going to go ahead and start with the two sliding window technique. So here is an article, a very good article from Geeks for Geeks. You can read about this and you know try to understand what sliding window is. The link is in the description below. You can have access to that to read about sliding window technique. Now, sliding window technique problems are problems in which a fixed or variable size window is moved through a data structure, typically an array or a string, to solve problems efficiently based on continuous subset of elements. This technique is used when you need to find subarrays or substrings according to a given condition. So the sliding window technique is essentially a technique we use to uh, extract sub arrays or substring from a given array, right? The array can be in any any it can be arranged in any order, right? But the point is, the reason why we use this technique is to you know extract a sub array from that main array, right? Or a substring from from the given string, right? And uh, in summary, it's just to get a contiguous you know set of elements, right, from a bigger or a larger string. So let me just continue with this. So sliding what is the sliding window technique? So sliding window technique is a method used to efficiently solve problems that involve defining a window or a range in the input data array or string, right, and then moving that window across the data to perform some operation within the window. This technique is commonly used in algorithms like finding subarray with a specific sum, finding the longest substring with with unique characters, or solving problems that require a fixed size window to process elements. So um what this means is we can be given an array, right? An array of a certain length, right? A fixed length array, and then asked to find maybe let's say for instance where there was an example that I also read about, which is the um finding sub arrays with a specific sum, right? Finding subarray with a specific sum. I'm just going to use that example to explain. But let's say so let me just come to this part here. This is my board. I'll delete everything I had on the board and start afresh. Okay, so um sliding window, right? Sliding window. The algorithm is, what it does is just, when you picture it, you will see it actually sliding, you know, um, a a sub array of the main array to get a final, a a final answer. Let's say, for instance, we have, an array of integers. I'll just put in some random integers. Let's say, 1, 3, 5, 7, and let's say -1 here. Now, let's let's try to find, um three elements in this array. I'll call this array X, right? Three elements in S, such that, when you sum those elements up, they give you the maximum value possible that you can have in this array. So how do we do that, right? So we know we are looking for three elements, right, in this array. So we want three elements in this array such that when we add them up, we get the possible maximum value from this array. So, as humans, right? So what we'd normally do is we'll find the sum at each point, right? We'll take the first three elements, right? We'll take the first three item in this array. So it will be here 0. Okay, I'll just do it this way. It will be at index 0, then index 1, index 2, right? Those are the first three items we have in this array. We'll find the sum, right? The sum of these first three. The sum of these first three will be, this is 8, this is 9. So we'll have 9, right? I'll call this F1. F1 is 9, or let's say max. The first maximum is 9. We know that we cannot stop at this point because there's more combination to do, right? So we've combined the first three. So the next thing to do is to create every possible combination, right? So we'll still go ahead and combine, 3, 5, and 7. So 3, 5, and 7, that will be 1, and then at this position here. So we'll find the maximum at this point here, right? We'll find the maximum here. So I'll say max again, right? Max again. This max here, I'll not repeat it. Let me just say, all right, let me just repeat it. I'll say max again will be equal to here 3, 5, and then 7, right? This is going to be equal to 15. So we'll have 15 down, right? Then we are still not done. There's more item in the string, so we'll go ahead and combine these again. We can do this. We can start from here 2, 3, and then 4, right? 2, 3, 4. We'll say max here is going to be equal to this. -1 plus 7 will give us 6. 6 plus 5, this will give us 11, right? Now this will be our value, right? And then we know we can't find any other combination because, we stop this. We only want three items, right, in the contiguous sequence. We don't want to, go ahead and do this. So we don't want to move up to a point because we always want three items. We don't want to go beyond the array, right? We don't have anything at this point. This place is empty, so we can't do that. All right, so when we stop at this point, right, we've found every possible combination that we can make with each items, right? We can create with each items up to 3, right? So because we want 3 items in the array such that when they are combined, we want to have the maximum possible value that we can get in this array. So when we compare each maximum, right, each maximum created so far, we can see that the highest value we have is this 15 here. This 15 is our maximum value. Now when you look at this, right, with the way I went ahead and found the maximum value, You notice I was moving one step behind and one step ahead, right? So in the first iteration, I had something like this. Let me just erase this. In the first iteration, I started from this point all the way to this point here, right? In the second iteration, I then move from this point all the way to this point, leaving this first item behind, this one here, right? And in the third iteration, I move from this point all the way to this point, right? Creating every possible combination with three items in the array, right? Based on the given inputs, we want three items from this array such that when they are added up, we get the possible maximum value from that combination. So this way of moving this, right? Let me call this the window, right? This this thing being moved here, right? This arrow here is called the window. When you look at it, when you observe this, you can see each time we are done, right? We slide the window by leaving one item behind and increasing the window by one, right? So this way of doing things, in terms of DSA, is called a sliding window. And when you read this article, you will understand from this, explanation what it is, right? So let me use this example here. Um, I'll use this example. This is 1, 2, 3, 4, 1, 2, 6, 2, 4, and 1, right? The window is of size k, so we want three elements, right? Size k here is 3, right? And we want to find the possible maximum from this operation. So here's how we're going to do it, using sliding window again. So we want three items, right? Three items in a contiguous sequence. We don't want to cross combine, otherwise we'll have to make every possible combination with each item in the array. But we want it so that in a way such that they are in a contiguous sequence, right? Contiguous sequence meaning they are one after the other, right? So I'll just use that example again. I'm just going to delete that. And this is 1, 2, 6, 2, 4, 1. So 1, 2, 6, 2, 4, 1. I'll write it here. 1, 2. Okay, let me write it in the middle. 1, 2, right? 6, 2, 4, and then 1. Right. This is our array. I'll just put it like this. Now the size of our window k, right, is denoted by k. So we have k here. K is equal to 3. So let me I don't think this is a problem. Let's take an example to understand this properly. Okay, so say we have an array of size n and also an integer k, right? Now we have to calculate the maximum sum of a sub array having the size exactly k. Now how should we blah blah blah, I don't know, that did not go with my flow. Anyways, but what this question, when you read this, right, what this question is asking us is, let's find a sub array of size k. K was given as 3, such that when we make the combination, right, the possible maximum we have from this array should be of size k again. So it's going to be a sub array, right? It could be anyone from this to this point here. Let me change the color. It could be from this point all the way to this point, which is of a certain size k. K is equal to 3. The length of the array has to be 3, and it's going to be a sub array of this array this array, I'll call it n, right? So we first of all find the maximum from the first three items, right? And then we move the window, right? Because we want to find the possible maximum of size k, right? The possible maximum sub array of size k. What do I say? The possible maximum sum or sum the possible maximum sum sub array of size k from this array n here. So the first time we find a combination of the first three items, we'll choose the first three items, and then in the next iteration we still have more combinations to the right. So in the next iteration we move the window towards the left, right? I mean towards the right. We slide the window across. So when sliding the window right, we leave one item behind, right? We do minus one item, which is this item here, right? And then we increase by one item, which is this item here, right? So each time we do that, right, we continue to get a certain maximum at a certain point, right? So we'll move the window here again, right? We'll leave one behind, add one again, until we reach the end of the array where we cannot move the window anymore, right? Because at this point it will be out of bounds. So we stop at this point here. Our window will be at this point. Now, how do we find this maximum? One of the ways to do this is to compute the addition at each time. So which means when we find, a maximum at a certain range, we want to calculate it, right? So we want to calculate it. So we'll do 1 plus 2 plus 6, right? This is going to be equal to 9, right? I'll just put max here. At first, this calculation is okay, right? This is going to be equal to 9. This is fine because we are calculating it for the first time, right? But when we move across, right, when we move to this point, when we move the window, when we slide the window towards the right, it means we are removing the first value, right, the first item from our previous maximum, and we are adding a new value at this point here. This is going to be at point this 0 1 2, and then this point here is 3. So at position 3 we want to add a new value to our maximum, right? Another way, a much less effective way to do this is to always compute this maximum at every window, right? So here again you want to calculate it like this by doing 2 plus 6 plus 2, right? This is going to be equal to 10, but that is not effective, right? Computing it each time, right? Doing 2 plus 6 plus 2 again equal to 10 is not effective. I mean, it is okay doing it for the first time, because at that point we are just starting at that particular window. So we want to find the maximum at that particular window. So we just take those three values, right, of size k here, right? We are going to use size k. All right, so that's what happens the first time. This way, computing the maximum at every window is not an effective way to do it. So when we look at this, right, we see that we are moving the window towards the right each time. So let's start again. We move the window towards the right, which means we are removing one item. Like I said before, we are removing one item from the sub array, and we are adding a new item. We are introducing a new item to the sub array. So the best way to do this is to subtract the value that we removed from the the main maximum that we found, the first maximum, right? We are going to do 9 minus 1, right, which is going to be equal to 8, and then we add the new value here, which is 2, right, plus 2. This is also going to be equal to 10, and this 10 here is equal to 10, and This way we do it more efficiently instead of computing this calculation over and over again, right? So each time we slide our window, we want to remove the previous value, right? The previous value from which we move the window away from, right? We want to remove that value, and then we want to introduce the addition of a newer value that we are adding to our, our window. So when we move this to the right again, right, we're at this point here, right? So what do we do? Again, we just do 10 minus 2, right? 10 minus 2 again. I'll just do 10 minus 2 because the value from which we moved away from is the value which we moved away from is 2. So we'll do 10 minus 2, right? And then plus 4, right? Plus 4. And 10 minus 2 is 8, plus 4 is 12. Now our current maximum is 12, right? And we continue moving, right? Because previously we had 10, so 10 is less than 12, so we choose 12 as our current maximum. And we continue moving, right? Because we are not at the end of the window, I mean the end of our main array yet, array n, right? So we move the window again, we move it towards the right. So introduction of a new value and removal of a previous value. So here's what we're going to do again. We just do 12 minus 6, right? Sorry, 12 minus 6 plus 1. 12 minus 6 plus 1 is just going to be equal to 5. And this is not bigger than 12, so we keep 12 as our current maximum, right? 12 is going to be our current maximum value here. Now this is how I learned the sliding window technique, and this is how I understood it for the first time, right? Because and this makes sense actually, because when we are finding a sub array from a larger array, right, such that we want to compute the values within that sub array to get a certain target, then this technique works just fine. Because I don't know which other way I would have done this. Maybe I would have created nested loops where I just start from here, right, and then I will just run an inner loop which is going to be the length of this k here, and then I compute the addition at each time, right? I'll just do every previous value, right? So I'll just do 1, right? Maybe I'll have like I'll use probably a pointer, right? Double pointer, and I'll have like a left and a right. A right is in the inner loop, right? So every time I iterate, for the first time, my left is going to be at this point here, right? And then my right pointer is just going to add every value, right? Every value, based on the length of this k here, right? I'm just going to do every addition. So I'll just do 2. Let me just go ahead and do that. And you'll see how inefficient this actually is. Is it raining? My network is gone. My network is actually messing up. Okay, so um I'll just try to compare. I'll just try and compare the sliding window technique against another technique that I believe probably work. So the technique is to use 2 pointers, right? So let's say I have a left and right pointer. Now my left pointer is at the top loop, right? An outer loop, a bigger loop. And my right pointer is just going to be an inner loop that run as long as the k here, right? As long as this k here. Now what do I do in this case? So first of all, I will loop, and the first loop is going to have the left pointer at this point. So left is going to be equal to 0 at this point here, and the value here is 1. So I'll add every other value based on the length of this r here. So based on the length of this k here, my inner loop is going to loop range. So it's going to be this value here, where the position at which L is. So I'll start from the position at which L is. So L, right? L L plus 1, sorry, L plus 1, because I always want to start from this point and add every other value to it. So L plus 1, right? L plus 1. And then I want to stop at this point here. So K, right? So it's going to start, this is going to be 0, right? 0, and then 0, then it will increase 0, then to increase to 1, and then 2, right? It will not include the 3. But when L is here, right? L is here, then L has to be equal to 1. And we don't want to do 1 plus 1 because yeah, so that's exactly what we want to do. Sorry, that's exactly what we want to do. We want to start from the next value here, right? This is going to be equal to 3, and then we just compute as long as, and we stop somewhere around here. But if you, like I said, this method is has a nested loop, right? It's not efficient. It has a quadratic time complexity, right? So it is not very efficient compared to the sliding window technique. The sliding window technique basically takes, a portion of the array, right, and then continues to slide it. And this is done with just one loop, right? It's done with just one loop, and it's efficient compared to this method here. I'm not sure if I explained this very well, but I'll just go over it again. um you know so I would say this is 1, 2, 6, 2, 4, 1. Okay, and k is equal to 3. All right, I'll just do it this way. I'll say y again okay, it was n, right? N is equal to an array like this: 1, 2, 6, 2, 4, and 1, right? And k is equal to 3. So what this means is we want 3 items, right? 3 items in the array to create a maximum value, right? So the way we do this, the way I would do this normally is to use 2 pointers, right? So my pointer will start, so I'll have an outer pointer. I'll just put a for loop here, for left, right? I'll just call this left, or just to reduce the words, I'll just call this L, right? Now L will run all the way here, right? L will run up to this point here, because I don't want to reach here and still compute an addition, right? So my L will stop here. Now how do I stop here, right? If you look at this, right, this is basically 3 item less than the length of the actual array. So here for L, right, in the range, I'll just put range of the length of this array here, this n array here, right, minus k plus 1. So right, so this will basically be equal to, so the length of this array here is going to be 1, 2, 3, 4, 5, 6. So 6 minus k 3 plus 1 is equal to 4, right? Hold on. Yeah, is equal to 4. So why do we stop at 4? So let's just say 1, 2, 3, 4, right? So I said it will stop at this point here. So this is at index 4. Now the inner loop will play the role of doing this addition, and this is almost similar to, what question was that? Using 2 pointers to find I think hold on. There was a question I solved like that. I can't remember. Um, it was, I think it was a palindromic question. Yeah, it was a palindromic question. Oh, sorry. It was, looking for a needle in a haystack. My bad. Because I remember I used this kind of technique. So, now you can see, you know, we continue to do the addition, right? Given the the length of this k here, right? The k is just going to act like our needle in a haystack, right? But this time around, we are not looking for a needle in a haystack. We are just going to look for the length, the highest amount we can possibly possibly create given the value of k. So the inner loop is going to have, so I'll just put for r here, right? This is going to be my right pointer. Now, what this right pointer does is, so when I'm at this position L here, and my right pointer will start at this point here. Now I will increase the right pointer given every value of L, right? So in my first iteration, right, so I want to loop up to the length of this k here. So range range length of what? So we want the length, we want, sorry, not length per se, we want to start from, l, but l plus 1, because we want to be at this point always in front of l. So l plus 1, right? And then we want to stop at k, right? Exactly at k, not k plus 1. K, because it will be 1 less than k. So if we looped through this, right, it will just go, all the way from this point. So it's going to be, hold on, hold on. You see, k here is not a length, right? Sorry, this is my bad. But we want to go from, we want to increase our loop. Oh, interesting, because in the first iteration this will work just fine, right? K will be equal to 3. L plus 1 is just going to be 2, so we are going to loop 3 plus 2, so we are going to loop the first time, right? Sorry, L is going, this calculation here is going to be equal to 1, right? So we are going to run the loop twice. So in the first iteration, let me just change this. In the first iteration, we'll do, again, let me just put our maximum here. Our max here is here, so max is going to be equal to you know plus equal, we are going to add to the max, plus equal the value at, the first value here, right? So plus every other value of r. So in the first iteration, this is going to be, I'll just put max plus equal the value plus equal the value at, this is n at l, right? So this is just going to add 1 to the max that was previously equal to 0. And then we'll just do this. We'll just say, okay, so the inner maximum value is going to start from here. So we just add n at r, right? So this loop will run twice, given the fact that this value is 1 and 3, right? So we are not going to run through inclusive. So here's what we're going to do. The right pointer is going to move from, it's going to start at this point, so we add 2 to 1 is equal to 3, and then we'll move it in the next iteration, which is going to be 3 plus 6, which is 9, right? So our first value is going to be 9. But then this is another issue where, we need to be careful. We always want to make sure that this loop runs 3 times, twice, starting from 1 plus the value of the um, original array. So let me just look at how I did it here. 1 plus the length of the original array. And this loop has to run 3 times. Well, if it has to run 3 times, then we don't need to do this way, right? We just put the k here, right? Range of k. I mean, it has to run twice, right? Range of k. So this loop is guaranteed to run from 0, 1, 2, right? But then we want to do the right pointer has to be equal to this. So I'll just say right pointer has to be equal to, so we'll compute the right pointer each time, right? So this is going to be I think this is quite confusing, but let me just kind of solve this out quickly. So my second loop has to start from here. So I'll call this j, and my right pointer is going to be r, right? So my right pointer at first is going to be 1 plus this value here, right? 1 plus this, and this j, in the first situation, j is going to be equal to 0. I don't want j to be equal to 0. I want j to be equal to 1, right? So that I start in front of r. So here my right pointer is going to just be equal to, let me move this down a bit. Christ. Okay, I don't think this wants me to move it. Okay, this is not moving, but anyway, I'll just manage to write here. So my right pointer is going to be computed every time. So it's going to be, at first, since it's going to be you know, the value of my right pointer, my left pointer, right, L plus j, right? So in the first iteration, where j is equal to 1, right, L is also equal to 0. So we'll start at this point here. R will be here. Second iteration, right, is just going to run twice. R will appear here, right? And then in the next iteration, we move left pointer to this side. And then the right pointer always has to start 1 plus 1 more than the left pointer. So this will work, right? This will work, but it's just not as efficient as using a sliding window. It's not as efficient as using a sliding window. A sliding window just has one iteration, right? It's just going to run based on the length of the input, right? We don't really need to bother ourselves about this k here, right? We don't need to really bother about that, but we know the sliding window is always going to run based on the length of the provided input, which is the array. And then we'll look into that array, get a sub array from that array. It could be an array, any iterable, right? Any data that has that is in a contiguous sequence. We will know how to extract the sub array using the window we've been given, and then just compute it. I think that's the way I learned about the sliding window technique. I'm just going to go ahead now and implement both technique, right? So I'll use my playground. So first of all, I will do the one that is not efficient. So let me just come here. Let me just come here and try out the first method. So the first method is just similar to what I did here. Where's the needle in the haystack? Yeah. So this is the needle in the haystack problem, right? Which is quite, good. But can we also use a sliding window in this case? Of course we can, right? We can use a sliding window to solve this. We can, given the fact that we continue seeing a match, then we are good to go, right? We are good to go. Otherwise, we'll always change the position of the window. We'll do it based on the length. Anyway, let me not just get lost into that. So I'll just say brute force solution, I'll call this what's the name of this question here? Today I'm just going to try my hands on the sliding window technique and see how, you know, efficient it is compared to using something like a two pointer where we have, you know, loops running inside another loop. Okay, so here's what I'm going to do. What's the name of this question again? What do I call this? Sub array sum. I'll just call it sub array sum. Right, so I'll define a function, right? Define, sorry, sub array sum. I'll call this sub array sum, right? This sub array sum is going to be a function that takes two variables. The first one being the array that we want to get the sum from, the sub sum from. So I'll just say, yeah. So this is going to be, what should I call it? Since we are going to be using integers, I'll just call this I can call this nums, right? Nums is just going to be a list, right? So this is something I need to import. So I'll import this name here. Num is going to be a list, and the second value is just going to be an integer. I'll call this k, right? K is going to be, you know, integer. Oh, and we want to, let's just call this n, right? N is a list, k is an integer, and we want to return the possible maximum. So that is going to be, you know, an integer as well, right? And that's about it. So we'll begin to implement our function now. So what do we do in this case? So I just want to implement my brute force solution at this point. So first of all, I'll create a maximum, the maximum that we want to return, max sum, and I'll set it to equal to 0, right? This is going to be equal to 0. And then here's what I'm going to do. I'll have so my left pointer is already there, which is going to be part of the loop. So I'll first of all loop through the, let me just come down a bit. So for I, let me not call it I, I'll just call it left. For left in range of you know, the length of the array, so length of n. Let me change this to capital N, right? So that, is this okay using capital N? Yeah, length of n minus k, right, plus 1, right? So this will make sure that we loop all the way to almost, you know, we loop through the entire array n, but just leaving enough space to do the remaining computation. Yeah. So here's what we're going to do. So we'll have our first I'll call this an inner max. So I'll just say inner maximum. And the reason why I will call this inner maximum is because we want to have an inner maximum that is computed in every iteration, right? So I'll have this plus, it's going to be equal to n left, right? So the value at n left, what's this? Why is this unresolved reference? I had not, okay, sorry. This is going to be equal to, so I need to set it to this at first. Yeah, this is okay. This is actually okay. We don't need to do anything. This is good, right? We start from the first value and then we add to it. Then we'll compare it with the other maximum and see which is the maximum at that current point. So here my inner loop will go this way. For j, I'll just call this j. I will not call it the right pointer because this is not the right pointer. The right pointer is one value plus, you know, the left pointer. So I'll call this J. J for J in range. It's not going to be range any. Okay, range. Yeah, range. Now we want to start from 1 and we want to stop at k, right? We don't want to reach. We just want to run this loop twice every time, 2 times. So then we'll go ahead and start doing other stuff, which is the finding out which value is actually the next right pointer. So I'll just call this a right. The right equal to right is going to be equal to the value at j, right? So the value at j is no, it's going to be n, sorry, n at j or l plus j, right? L plus j is always going to be one step ahead, not l, so left plus j, sorry, left plus j, right? So we have this, and yeah, that's our right pointer. Then we will do this, we'll find you know, we increase the inner max. So inner max plus equal the value at the right pointer. So n at right, okay, and then this will find our maximum for us in the first iteration, in the second iteration, and so forth. So once we've computed this inner max, right, we want to set it as the maximum, or at least we want to compare it to our previous maximum. So max sum is going to be equal to you know, the max we are looking for, sorry, we are looking for the maximum. So max max of right, is that not what we called it? Why is it not referencing it? Okay, max sum is going to be equal to max sum and then the inner max here, like this. And then, you know, each time we found a maximum, we'll compute that as our new maximum. Then we just return at the end of the day, when this loop is done, we'll return our max sum here. Okay, so here is what I think is, you know, a solution for getting the maximum sub array sum, giving a I'll just call this a coefficient or a sub array length, right? So let me just go ahead and compare it with my here, where's the board? I'll just, somebody, thank you very much, somebody just, you know, that's nice, thank you. All right, I don't know how to pronounce your name, but yeah, hack. Okay, let me not spoil your name. All right. Um, so we know our maximum here is equal to what? So let's just go ahead and do this. I think we found, was it 12? Let me just go ahead and do it again. I will erase everything. So this one, where's my, okay, this is 126241. So I'll just go ahead and verify that. I'll come here. 1, 2, 6, 2, 4, and then 1. Right? This is our value. This is our array, and we want, you know, the maximum between 3 items, right? So our first window, our first iteration, right? In our first iteration, L is going to start from here, right? And then R is going to start from here, right? And increase all the way to this point. But let me just, so first iteration, L is equal to 1. So our first inner maximum, sorry, our first inner maximum is going to look like this. So it's going to start from, 1 plus this value here, right? We are making r equal to, 1 plus L, right? 1 plus L, which is the left pointer. So this is going to be 1 plus 2, and then we move r again. Let me erase it and write it properly. Otherwise, I'll not be able to move it. So I'll just put r here like this, which is awesome. So here, I'll move r to this point, right, and add the value. So this will be 2 plus 6 again. So plus 6, right? And this is going to be equal to 9 because our inner loop will stop at this point. So we'll have to go back up and increment our this thing. But before we do that increment, right, we know our main maximum that we are looking for was equal to 0. So the maximum between 0 and 9 is always going to be equal to 9. So 9 takes the lead. Now our maximum becomes 9 now at this point. I'll just set this to 9 and erase whatever I wrote here. Oh my god, I shouldn't have done that. I want to erase this. Right. Okay. So in the next iteration, we'll move our left pointer towards here, and our right pointer will start from here, right? But our inner max value will start from here. So initially it will be equal to 2, right? I'll just put inner like this. I'll call it in. So is it going to be equal to 2 plus 6, and then we move r by 1 again. We'll move r by 1, right? We'll move r by 1. 2 plus 6 plus 2, right? Plus 2 plus 2. And this is equal to 10, right? 10 is, larger than 9. So our maximum becomes 10, right? So I'll just set this to equal to 10. All right, so we move L again by 1. We'll move the left pointer again by 1 in the next iteration. Our right pointer will start from here, and then we'll do our computation again. So let me erase this. So in is going to be 6 plus 2, and we'll move the right pointer again by 1. We'll move the right pointer again by 1 plus 4, right? 6 plus 2 plus 4 plus 4. This is going to be equal to 6 plus 2 is 8 plus 4 is 12, right? So our new maximum now is 12. So I'll erase this again and set this to be equal to 12. Then we are not yet done with the iteration. We'll still move our right pointer here, our left pointer here, and start our right pointer from this point. Always 1 plus the left pointer, right? So I'll erase this again. I'll erase it again and, do the computation. So I'll always, add, so 2 plus 4 plus, we move this by 1 again. We'll move this to this point plus 1. Sorry. Plus 1. This is equal to 7. And, 7 is not bigger than max, which was, 12. So 12 becomes our answer, and we return 12 at this point. We can't continue increasing this L because the condition was such that we stop at the, the entire length minus 3, right? Which is the value of k. So let's use this value, which is 126 and 241 and k, which is equal to 3. So I'm just going to come here and call my function, which is the, I have caps on, subarray sum 126, and then 2, 2, 4, 2, 4, and 1. Then k is equal to 3. All right, so this is our value, and we need to print this to see the results. Sorry. I'll just print this, right, and just print this. Okay, now we have an issue. Our issue is that we are increasing. Oh, I see. We are increasing this beyond where it's supposed to be. And how is that happening? Let me just think about it. Left plus j is going to be equal to uh this is interesting. Let me see. Is this array actually 241 126 241 126 241 126 241? Okay, that's good. Um, let's check again. Let me just cross check and confirm. 126 241. What is happening here? So in the first iteration, that's going to be here, and n left plus j. Yeah, we're always making sure we are out in within. Why is this happening? Oh, you see, this is the mistake. I'm already calculating r there instead of doing it this way. Okay, now this should work. Yeah, there's no more errors. We should have 12, which is our, total. Right. So that is a brute force solution to this question, but it is not efficient. And, because we are really concerned about efficiency and, runtime, uh, calculations and all of that, because every computer is not the same, right? If this solution is not effective in terms of time complexity, this place here, we are not even creating any more memory in space, so we don't really bother ourselves about, you know, space complexity. I mean, we don't really have to, the time complexity is not really based on the machine itself, right? The computer you're using to run the algorithm or to run the solution. But when it comes to space, right, that is where the we need to take in account the memory of the computer. So this is good. It works, but it is not effective as a sliding window. So I'm just going to go ahead and implement the sliding window technique. I wish there was a way for me to, kind of test this in LeetCode. I don't know if LeetCode has a sub array sum question. I'm sure they do. Sliding window here. Minimum length. I want sub array sum. So that I can compare both solutions. Maximum. There is, but I did not plan to solve any LeetCode questions today. I just wanted to, explain how I understand the sliding window technique compared to every other algorithms that are not as effective as the sliding window technique. Oh, somebody is saying hi in the chat. Yeah, hello. Um, okay, so are you trying to find the biggest number in the array? No, we are not trying to find the biggest number in the array. We are trying to find the biggest the maximum value given you know given a sub array in the entire array. So let me repeat that again. So what we are looking for is an array that is equal to an array whose length is equal to k, which is 3, and we are finding every how do I explain this? So we are finding a sub array, right, whose length is equal to k, which is part of this main array here. I'll call this main array n, right? We are finding those subs array, right? And then we are also computing the sub array, the values in the sub array. We are adding every value in the array to find the possible maximum value we will get when we look through the entire array after we form three subs array, three Okay. Let me go over that again. I think what we are looking for is a sub a sub maximum value, right? A sub array that has the maximum value when you add every item in that array. So what do I mean by that? I'll just come here again. So here is our array, right? Now we are given a value k. This value k indicates this value k is just means the sub array we need to create in this array here, right? The length of that sub array has to be equal to k. Now after forming that sub array, which is part of this array n here, we need to find the maximum value of, we need to add every value in that sub array. So in this case here, we will have like 9, right? This is the first maximum value we found after creating the sub array. So we need to create the sub array as many times as we can, right? So the first time we create the first sub array is going to be from this point to this point here, right? And the value of that sub array always has to be 3, right? So in the second iteration, we have to start from this point all the way to this point here, and so on, right? So we'll start again from here all the way here, and then from here all the way here until we reach the end of the array. So we need to create sub arrays of the main array, and those sub arrays have to have the length. Their length is going to be equal to k, which is 3. And then after getting those sub arrays, we want to add every item in that array to form a single value and compare it to every other sub array that we've created so far and find the maximum value possible that we can get. I think that is what you're trying to understand. If you don't get it, I will go over it for you again. But if you get it, then I'll just continue, and implement the sliding window technique. So the sliding window technique, like I explained in the beginning, is just, first of all, finding the possible maximum, right? And then subtracting the previous value and adding a new value each time. So we subtract, we remove, we add, we remove, we add, right? So let me go ahead again and explain that one more time. So I'm just going to do this. So the sliding window technique, right? So I'll represent this as our window, this here. This is our window, right? And the length of the window is the value of this constant k here, which is 3, right? And we want to move the window across, right? We want to move it to point at each element in the array to create a sub array, right? So, and every time we slide the window towards the right, we want to find the total at that interval. So here we are going to start at 0, right? So the value here is going to be 1. The first maximum we find here is the position at which our window is in the first iteration, right? So here our first maximum is going to be equal to 9, because 1 plus 2 plus 6 is equal to 9. Now we need to move our window towards the right by 1 element, right, or by 1 item in the array. So we move this towards the right. Now our window is going to point at 2, 6, and 2 again. So we find the maximum at that point, right? We'll still do 2 plus 6 plus 2, right? And this will give us 10, right? 10 is superior to 9. So we know 10 because our current maximum. And then we do that for every other value until we reach the end of the array where we can't move the window anymore, right? So we'll move from this point to this point. This will give us 12. And when we move from this point to this point, we know we can't do this anymore because the window will fall outside the array. Now, one issue with this is computing the value every time we're at a certain window, right? Like I said, I was doing 2 plus 6 plus 2 again. This is not efficient, right? This is not efficient at all. So the best way, because if I did it that way, it means I will run a loop to do that computation or to calculate it again. At least it will require me to run a form of iterative calculation on each item in the array. So to do this in the best possible way, right, using the sliding window, is to remove one item, right, from the maximum value we found previously, and we'll add one item to it, right? So here is what I mean by that. So when we find the maximum at this point, we know the maximum is going to be 9. So when we move the window by one item, right, it means we are removing one from the window, right? We are removing one from the previous value. It's going to be equal to 9 minus the position at which we move the item from, which is going to be equal to 1. 9 minus 1, and then we'll add one more item to it, which is going to be 2. So introduction of a new item, 2, right? This is going to be 9 plus 2. This is equal to, 9 plus 2 is equal to 10, right? It's the same as computing this value over and over again, but this time around we are doing it more efficiently, and this loop is just going to run only once, right? We don't need to run this loop twice. So in the next iteration, we will do the same thing again, right? We'll move this by 1 and increase the right by 1. We'll move it 1 away from the left and increase the 1 on the right. So again, we'll do 10 minus 2, right? 10 minus 2, and then add 4 to the value, right? So this is going to be 10 minus 2 plus 4, right? This is going to be equal to 12, and then we'll do the same thing again, right? And every time we find a maximum, we want to keep that maximum at each point. So we move this again, we do minus 6 plus 1, and this will be equal to 7, and 7 is less than 12, so our current maximum is going to be equal to 12. And that is how you solve this question using the sliding window technique. All right, so let's go ahead and implement the sliding window technique. So we first of all need to, so I'll just come here. I'll call this, let me create a sliding window folder. So directory, sliding dash window, right? Sliding window, and our first one was a brute force solution. I'll call this sliding dash window brute force. I'll just call this brute force solution, and then I'll just copy this from here, and yeah, I'll just put this here, and then I'll create another file called the actual sliding window let me not call it, I'll just call it math sub array sum. I'll just take this value here and replace it with this one, but I'll add brute force to it. So I'll just rename this to brute force dash brute dash force here. Okay, so that's our brute force solution, and here's what I'm going to do. Let me just check. Chat rate is C0000. Okay, that's good. Okay, no question in the chat. I've refreshed. Let's go. So we want to implement the the sliding window technique, right? So how does the sliding window technique work? We know we first of all have to compute our first maximum, right? First maximum. So I will just use the same. I'll copy this. It's going to be the same thing. So here we have our maximum. We just want to return the maximum at the end of the day. And the first time we need to find the first maximum. So the main maximum max is going to be equal to what must be equal to. Max will be equal to max will be equal to max. I'll call this max. What did I call it here? Max sum. Okay, max sum is going to be equal to. I'll just use. Let me not be lazy. So, oh god, I wanted to. Yeah, this still works. I mean, I would have written a loop to find the maximum, but I mean, I can just do it this way. So I'll just say n, right? Every value from 0 all the way to the length of this k here. So I'll just do it like this. This will take every value from 0 all the way to k and find the maximum. Let's just try this out. In our playground, I'll just, put this like this, right? I'll create n. N should be equal to this, and k should be equal to that. You'll see that the first result is going to be equal to 9. So here, right? So this is going to be equal to k equal to this. Oh my god. K is equal to this, and here we have n, capital N is going to be equal to that. So you see when I print max sum, the value will be equal to 9. Yeah, so you can see 9 in the console, which is okay. Alright, so let's go ahead and do it here. So this will first find 9, right? So then I'll just go ahead and run the loop from 1 plus, I'll start from here. Let me go here. Let me start here. Where's my board? So after calculating 9, right? So my loop is no longer going to start from the beginning, right? My loop is going to start from here, right? From here all the way to there, right? Each time. So I'll just jump one extra. Okay, so that's about it. And I found my first maximum, right? And my loop is just going to, so for, what should I call this? I'll call it left. I'll call it left, right? For left in, so my range is going to start from 1, right? 1, and yeah, so for range is going to start from 1. So 1 all the way to all the way where I want to stop at 1 less than this, right? So it's going to be equal to the length of the array minus k plus 1, right? Is that not going to be it? So length of the array is going to be here. So if we start from here, right, we want to do, we don't want to do that. We actually want to start from 0 so that we can do minus 1 from this value here. So from the main maximum that we found outside. Oh my god, my time has elapsed. Let me just go ahead and do that first. So what do I do? I think I might have missed the step, but let's just go ahead and So in my first iteration, I want to do minus one item plus one item. Okay. So which means I'll have to start from zero, right? I always have to start. I will have to start from zero. Instead of calling this left, I'll just call it I, right? I'll just call it I. And here is the problem I'm having. So I want to do minus one plus one, minus one item plus one. Um, I can do this, right? So length of the n minus k plus 1. This still works because we don't want to reach the end of the you know iteration. But I'll just again, ouch. Again, I will take our first maximum, right, and compute it to remove the last item from it. So how's that going to happen? Let me just say this is going to be inner max is equal to um inner max is going to be plus equal, right? Plus equal the we do nah, hold on. Sliding window is tricking me. I was talking too much, so I probably I probably lost track of what I was saying. So I want to slide. So first, in the first iteration, I want to do one minus one item minus the previous value and add one item to it, right? Okay. So if I start from this point here, right? So this is going to be equal to probably it's always going to start from zero anyway, which is not entirely bad because I want to remove the first item, right? What maybe I should just hold on. Um dun, 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 dun. No, no, no. Sorry, I think I'm confusing myself. Um Wait, where's my board? So, because I want to have like a position where I'll always keep track of which item is has been removed, right? Not the item that has been removed per se, but it could be either, right? So I can have like a let me just think about this. So I found my fixed maximum. So here, let me just erase this. My first maximum is going to be everything here, right? Now, the next time I find a maximum, I want to reduce the maximum by the first item in the array and then add the item at this position here. Okay. So, which means every time I iterate, right? Every time I iterate, so the iteration index or the iteration factor is going to help me reduce that value each time, right? So I can reduce this again by that, and yeah, I'll stop here. I'll stop here. I'll stop here. I'll stop here. Okay, so minus this plus that, minus this plus that. So to do the reduction, the iterating index has to increase each time, which is well okay. So how about the addition? Where are we adding from? So I think the addition here, this is the length of the array, right? So okay, this is the length of the array. So when we move this, right, what does this represent? This is going to be equal to 1 0 1 2 3 0 1 2 3. We are here. Is this the... So how do we get this value here, this last one, to add to it? Because it has to increase every time. It has to increase here, from here to here to here. So how do we increase it to this point here? This k here is 3, right? 3 plus the index here. So when we are at this point, if we want to move this here, so this is going to be equal to 3. So 3 plus the index. So at this point here, I would have increased by 1. So this is going to be 3. 3. So is it going to be 3? I would have said 3 plus the key, right, which is the value of j. J plus k would have given me this, but you know that only works in the first iteration. Yeah, that's what I want, right? So the first iteration, we want to do minus the first one plus this one here, which means the window will move. Oh yeah, that is it. So I think I'll do plus j plus k will give me the last item, and then I'll just reduce. I think that is it. So here's what I'm going to do. So I'm going to compute, I'm going to find in fact I want the maximum, right? I want the maximum at that point. What would that maximum be? Because that maximum has to change every time. It's from that maximum we have to reduce, increase. Maybe I should just put that maximum as also the first maximum, right? So let me just say max inner. I'll just call this our inner maximum, inner max, and the value 2 is equal to this, right? Everything is this. So inner max, right, inner max will be like this. So inner max, so I want to reduce it by okay, first of all, let me increase it by the value I want to increase it by. So n at j, I think n at I, sorry, I plus k in the first iteration is going to be 0. It's going to be 3, which means we are going to start at index 3. We are adding index 3 item. Sorry, we are adding index 3 is what? Here, right? Index 3, that is cool. In the next iteration, when I is equal to, now I is now going to be equal to 1, meaning we are removing this and we are adding this, right? So if I is equal to 1 and we are adding 3 to 1, that's 4. So it's going to be the fifth item, right? I is going to be equal to 1. So I is going to increase to 3 in the next iteration. Yeah, this is good. All right, so I'll just do this. I plus k, right? Right, so I'm adding I, which is the last item that I'm adding, and I'm going to just remove the last item, the first item, which is I, from it, right? Oh my god, I didn't put this here. So here, oh sorry. So here, inner max is going to increase, decrease, and then we'll find out which one is the maximum. I think, yeah. So I'll just, okay, nothing much is going on in the chat. So I'll say max sum here is going to be equal to the max between these two after computing. Sorry, note that. Yeah, it's going to be these two. So max sum and inner max. I think this should work. So return the max sum at the end of the day, and that is our first sliding window. Print sub array. I'll just copy this from here. I'll copy this and print it. So let me just run this. Oh, wait, hold on. Okay, it's not. Oh, sorry, my bad. We just have to assign. Christ, what am I doing? So I want the item at this point here. Sorry. I knew this was going to happen out of range. My internet just went off, sorry. Maybe I should just go ahead. I think I should just look at how, it's implemented again. Here, they did it here. So we are looking for the first maximum. The current sum is going to be equal to 0 n minus k. Yeah, we are looping this much. Oh, this is a brute force solution. I don't think this is. If we're sliding the window, yeah, it should just be 1. So when you read this article, you actually understand what it is. So here is what the calculation actually is. So we are doing window. What was I doing? Hold on. If I'd I see. This is not good at all. I'll just call this I'll just say outer max, and I'll say this is maximum, inner max here, inner max k, and I wasn't even doing the calculation very well. So I want to subtract the first item, so which is the outer max You know, wait, hold on. Let me see. So Windows sum, right, is equal to Windows sum minus, yeah, plus this. I think I'm exceeding my this thing here. Yeah. So let me just go back again. Yeah. Instead of going all the way, I want to stop at 1 minus, because here this would have reached the this position, but I'm still increasing it by 1 here. Where's my, I'm still increasing it by 1. This would have been at 3 minus 3, right? So we want to stop at this position here. We don't want to go beyond that. We don't want to add more items at this point. After removing this and adding this, we want to stop, right? We don't want to remove this and then add something else again. I think that is how we should. Let's run this now. Yes, this is our. My network is really messy now. I think they've taken light. They've taken light. They brought it back. But yeah, so there's okay. Thank you very much to Shushman and learning Python. Python. I'm not saying very well, but yeah, it says for which development do you use a sliding window? I think it should just come up naturally in your problem solving cases, right? When you have, like, you are facing a problem, and I've not done it extensively to know where I'm going to use it, but it's just something you that is good to know, in order for you to uh, use it when you encounter, it could be anything. It could be developing a website. You want to do some, some JavaScript, animation. You want to just do something really fancy. You can then go ahead and use it, right? You can just use it. Maybe you want to create a slider. That's like another way to think about it, right? You want to create a slider that slides across, that pans across certain items. Then you can still use it in that case too. I've not done it yet, but I believe it is possible. All right. I'll see you guys tomorrow, and thanks for staying through this session.